So now on to Gerry. So Gerry, short bio he sent me, he began his academic studies in New York and completed his PhD at Colorado State University. He's 30 years experience in private industry and in academia. He's the president and chief scientist at Nighthawk Weather, which is a cool name for a company, in San Antonio, Texas. And he's emeritus member of the American Meteorological Society and has over 40 publications, presentations, webinars, and posters in meteorology, education, and ethics. And I'm delighted to have him here to add one more to those presentations. So Gerry, please, whenever you're ready, you can start your talk. Thank you.
Okay, I will go ahead and share my screen and bring it up full. Okay, so this work actually was one of my students, Louis Leva. Louis graduated, and this was his senior project. I worked with him on it to get him started. And when I saw how interesting it was, I decided that I wanted to share it, particularly with the Irish Meteorological Society. And Louis is right now, he's involved in his studies for his Master of Science degree in business. And he has an exam right now. And he had very, very tight timelines. So he graciously allowed me to put this presentation together and actually to give it in his presence. Or he will be logging in when for the video when this is over and he has some time to work on it. So the background is we know that the sea surface temperatures in the North Atlantic Ocean area have been rising over a considerable length of time for the areas just south of Greenland. We also knew that warm sea surface temperatures are conducive for hurricane formation and persistence. It's just one of the factors which are there. And we had seen in a period from about 2004 to 2013, some other researchers had seen that there was an increase in the frequency of tropical, trans-tropical, or extratropical cyclones that are actually getting out, recurving back from the tropical oceanic waters in the Atlantic and impinging on Northern Europe. And that we know that once they get out of the really tropical, like good, juicy, warm, moist water with a lot of both latent heat transfer and sensible heat transfer, that they eventually lose power. And if the conditions are correctly, they'll actually transition into an extratropical cyclone. Now, this is one of the things which actually triggered my interest. This was a Met-Erin analysis, and I can't find out where it was from. But when you do research, you kind of pick up things here and there, and they kind of lock in your interest. And this is one which looked at the number of storms identified by low pressure core centers less than 950 hectopascals, and the frequency of their currents versus time. And as you can see with this particular diagram from 1960 or so to 2000, the number of these rather intense lows coming into the European area had increased dramatically. So the question then for me became, well, what are these storms, and is this related in any way to some things going on perhaps in the ocean or in the atmosphere? I apologize, I don't have the reference for this, but perhaps someone in the audience can recognize this from a presentation and enlighten me more on it. But this is what triggered my interest. And then, of course, my student was very interested in tropical storms. And so he took on this research. The work that's gone on before it showed that we had an increase in sea surface temperature, we had an increase in tropical storms, and we had an increase in these trans-tropical storms. as they kind of reached the top level of that baroclinic zone, which rides just below the cold air and cold polar air, runs right on that border. And we also saw that there's a shift in the track of these tropical and trans-tropical storms. It was shifting north. And we also noticed, Michaelis and Lackman noticed that these storms became stronger as time progressed. So kind of interesting back notes for why we wanted to actually start performing this research to investigate this a little bit further. So this is the 46 tropical storms that fell in this time that we were looking at. And this box you see there is the study area we had. These are the individual storm tracks that NOAA actually produced as they tracked the storms. And you can see the obvious recurvature from the tropical regions up along the eastern seaboard of the US, and more or less following the Gulf Stream as it was moving north, as it moved north along the East Coast and then turned towards the east as it got past Newfoundland. So with this, we started looking at this area and what was going on in this area to see if there were some interesting factors occurring. So we took this area, and the definition was between 30 and 50 degrees north latitude and between 20 and 60 degrees west longitude. So we subdivided that into 1 degree cells, and this is kind of following what had been done by some previous authors because we wanted to see how our results would look compared to them. And we had just under 800 data cells we analyzed. Unfortunately, 4 of them in the retrieval process that we used to extract the data from the National Oceanographic and Atmospheric Administration database failed. It tried it several times, and there's something wrong with those cells. We were unable to retrieve any data in there. But we were able to pull the 2 data sets, one from the 1987 to 2002 time period, and then 2003 to 2018. So we're talking about 15 years or so worth of data. And what we did was we extracted the seasonally average sea surface temperature from the most active hurricane season in the tropical regions, and that is in the August to October time period. And then we started looking at, is there a difference between the sea surface temperature? Because if the hypothesis is that a hurricane is able to last longer as it is recurving, perhaps the sea surface temperature is providing both the latent heat and the sensible heat that would drive this. So one of the factors that you actually look when you forecast hurricanes is sea surface temperature down to a depth of about 150 feet or so. So we looked at the seasonally averaged anomalies, and we performed a student t-test on these 2 different data sets to see if there's any difference in the sea surface temperatures. And we also did some other things. We also looked at the maximum wind speeds and also the minimum pressures of either the tropical storm, the trans-tropical storm, or one that had transformed totally into an extratropical cyclone. So here's some of the results we had. And this is the number of storms that actually reached the edge of our box, which was that 20-degree line entering in Western Europe as a function of time. starting off in the mid 1960s, going out to about 2018. What we saw is this a lot of scatter in the data, but we saw what we thought was a pretty good trend, increasing the number of storms per year from, if you start as a base back in 1960. And by the time you got out to 2020, you're seeing 2 storms on average that actually reach the Western Europe area. And this is just a trend line. You can see that actually in the 2018 period, there were 4 storms. These are storms which were identified as hurricanes and made that recurvature. So it wasn't based solely on lowest pressure or central pressure or on wind speed. It was following these individual hurricane tracks to look at them. And so we saw this increase. So this kind of is along the same lines as this data that we picked up from Met-Erin, that there's an increase in storms, or rather severe storms, coming into Ireland and Western Europe. We also took a look at the sea surface temperature. Now, this is this data set is again the August-October time period when you have maximum generation of hurricanes. And the time frame was again 1987 to about 2000. And we looked at the anomalies, and we looked at them as averaged over this time period for those approximately 800 data points. Now, I would point out here that if I left those 4 data points in there, the graphs would have looked very funny. We'd have seen the spike go down. It's just an artifact in the data. So rather than do that, I averaged the data in adjacent cells so that you could get a better idea of what the plot actually was. And this particular plot shows that, yes, the average sea surface temperature anomalies were a little bit less than 0.3 of a degree C. And that across this whole area, these anomalies were occurring. So it's not just one location or 1 year. It's a larger scale of an event. And the maximum anomaly here is just a little bit over, or just a little under about 0.45 degrees C. So this was the kind of period that the previous authors had looked at and had made some generalizations that the number of severe storms from a tropical nature hitting Ireland would be increasing. Additional work was done in a modeling sense to project outward past this point and look at years in the future. Again, they held the same trend, that the number of storms would be increasing. But there's some differences in the anomalies, and I'll address that at the very end and leave that as an open question for the audience. So this was the basic work that had been done before. We of course did the averages just to print this out and make it visual. This is the time period we actually started looking at, and you can see right about the region farthest north in our analysis, and right around the point of just south of Greenland, we saw very dramatic increases in the sea surface temperature anomalies. And overall, the average sea surface temperature anomalies were more than they were in the previous period. So we've gone up from 2 point something or other to about 0.2 something other to 0.5 something other degrees C. And the maximum anomaly went from 0.44 to 1.29 degrees C. And it's up in that area, and you kind of expect this. If you were to hypothesize that the Gulf Stream was strengthening, you would expect to see further towards the west, in the northern regions where the Gulf Stream could push back the water coming down from the Arctic Ocean, you would expect to see these anomalies perhaps more pronounced. So with this, we actually started also examining storm pressures and the wind speeds to see if, is there a trend in here? What do we actually see? So we recorded the pressure when the system left our study box. So it's just as it's coming out into Western Europe. And we also made the wind speed recording right when they made that extratropical transition, or if they had already made that transition when they actually left the study area. So the trend we'd see here, and this is the data, and on the left-hand side, those last pressures, and you can see that they're varying up and down as a great deal as you'd expect. The trend line I put in there was kind of interesting because it's now bringing the pressure, last pressure, down to about 980 hectopascals. Looking at the wind speed, there's very little trend in the data. There is some trend downwards, but there's still a lot of noise in the data to actually make an assessment of that. And this is from the total of 46 storms. So we looked at the sea surface temperature anomaly, and we performed the student t-test, and lo and behold, the difference is significant. So there is a significant difference between the two, and visually you would say, yes, that is, but of course, there's a lot of noise in the data. So we're actually seeing a warming in the North Atlantic, just off upwind of Ireland. Of course, Ireland is one of those countries which is solely at the mercy of the the upwind oceanic area for its weather. Whether it's coming in from the south, or you're actually getting that cold Arctic air coming in from the northwest, that's what's controlling the weather in Ireland. So we did see this difference. We saw a difference in the number of storms. We saw differences in the strengths of the storms coming into Ireland. So with this, we had an interesting question. And this is the one which I always like to leave my audience with interesting questions. And this is one which is, given we see some periodicity into this Atlantic meridional overturning circulation, the period of this oscillation is somewhere between maybe 40 and 60 years. We don't have enough data to actually pull that out. But we're now on the warming trend of that. So this oscillation is now increasing, and we're seeing in this time period, we're beginning to see more and more storms, and more storms impact Ireland. So the next question is, well, what is this meridional overturning circulation? Is there something on top? Is this on top of the general oceanic warming? Some analysis which I have seen, and I have the references are at the end of the talk, indicate that there is a trend increasing the sea surface temperature anomaly in the North Atlantic as a function of time on top of the general warming of the oceans. So this wave, if you will, this temperature wave due to the overturning is actually superimposed on a general warming of the oceans. So another question that pops up is this related to this projected westward shift in the warm tropical surface waters that hurricanes generate in? And the studies that I have read say the data is too noisy to tell. We can't yet detect statistically this shift in tropical surface waters more towards the west. But if it did, it would make sense that storms would then be energized further before they did the recurvature. And if the Gulf Stream is, and indications are the Gulf Stream is actually warming, it would help preserve the structural integrity of the tropical storm further north before it would undergo the transformation into the extratropical storm, or maybe even a transtropical storm. So in summary, we looked at these seasonally average sea surface temperatures anomalies in the mid-Atlantic, and they are increasing. The number of tropical cyclones and extratropical cyclones and transitional storms, which are generated from these tropical storms, are actually, the numbers are actually increasing as they reach Europe. The numbers reaching Europe actually increases. The past trends of storm pressures reaching Europe, they have changed. They have decreased by 10 hectopascals over the 50-year period. So storms are becoming more intense. The winds have decreased slightly, but again, I wouldn't put too much faith in that, and the data is not does not have a clear enough signal. And the data from the study shows an increase in the tropically related way storm impacts on Western Europe. And these storms coming in are, and as I'm sure most people in Ireland can see over the last 10 or so years, or 15 years, the more of these extratropical storms that actually make it to Ireland, they bring with them these high winds, heavy rains, and occasionally even tornadoes. So at this point, I'd like to thank the Irish Meteorological Society for allowing me to present this work. It's more of a question, it's more of a start than it is a conclusion on anything. I know Lewis was very disappointed he couldn't be here even to hear this, but I presented as part of the work he did to get his Bachelor's of Science degree in meteorology. And so now I'm interested to know what you all think about this. And by the way, I do have references, and I did put backups, data sources, some of the other development material that I had in there. I put that as a backup for anyone who wanted to do additional research, and hopefully this does trigger some additional interest in this area. Thank you.
That's great. Thanks very much, Gerry. That was really interesting. Could we all give an applause either by actually clapping, what a crazy idea, or by using an emoticon to show Gerry our thanks. Thanks very much, Gerry. Great talk. So brilliant. I really like the way you presented that, Gerry, as kind of an open, ongoing investigation, as opposed to, a kind of a sealed and delivered result. It was really good. And in terms of impact, obviously, it's something that's of great interest to us here in Ireland, because that's exactly the area that you're looking at, things that are traveling through and transitioning across to us. So I have a few questions I'd love to ask. For the rest of you, feel free to add any questions you may have into the chat box, or indeed, when I stop asking questions, you can ask one yourself as well. I'll start off with the same one that Nicole posted, which is just something that occurs to me when I'm always looking at anomalies. Gerry, do you know what the baseline reference time period was that you used to calculate the anomalies against? Oh, actually, we seem to have lost your sound,
Okay,
Gerry.
I got it now.
You're back.
The baseline was 1960 to 1990.
1960 to 90. Okay, excellent.
And
so
I think I put that in the charts in the back.
Okay, cool. So 60 to 90. So there was quite dramatic warming, certainly in the northwest region towards the end there, which is really striking. And I guess something that it's a real advantage of revisiting some results and re-looking at them. I mean, a lot of people may have averaged the North Atlantic region, in which case you would have lost it in the noise. You know, that 1.5 degree spike that you're finding, you know, near Greenland or the northern region of that area could have been lost out by a lot of other analysis that would have just averaged over that region. So that's really interesting to see. One of the things that I was wondering when I was looking at this is, you know, it is reasonably noisy and specific things you're looking at, and maybe a short enough time series to draw a lot of conclusions from. I was really interested to see then that slide that you put up about the AMOC, the overturning circulation, and you mentioned these longer natural variability cycles that could have quite an impact on this kind of thing. I've got two questions about that area. One of them is purely my ignorance. What is pi, or the squiggle pi thing that was on the right-hand side of the AMOC? You had the surface seas temperature in red, and then you had two black lines that were labeled pi.
You know, I can't answer that question. I'd have to go back to the reference.
That's all right. I think one of them might have been a measure maybe of would it be a measure of the speed of the Gulf Stream? It seemed to be a velocity.
It could have, yes.
So in the context of that plot anyway, which went back, you know, a lot further, was it 1800, when they're trying to reconstruct ocean currents, which can have decadal scales in them. Did you have any thoughts of using something like the 20th century reanalysis or some other longer term reanalysis to try and approach the question of changes in hurricanes over maybe longer timescales of 50, 100 years?
Well, we actually were looking at these two data sets we looked at. One was from the 1986 to 2002. They actually looked at it from a modeling standpoint. They modeled forwards and they modeled backwards. Now, the older the information on hurricanes gets, the poorer it actually is. You know, when we started getting satellites, we began seeing much more of these hurricanes. And that was in about the 1960s, early 1960s, when Tyros first went up. Before that, you could have had a hurricane out there, which, other than a report in a ship's captain's log, you know, you may never have seen it. So we didn't want to go back too much further than that, because the quality of the data becomes suspect. You would normally, you know, because of those kinds of limitations on observations, you would say, okay, you know, even though you saw fewer storms back before 1960, is that really true, or is that an observational problem? So we didn't want to go back that far. But I know some people have done some climate modeling, high resolution climate modeling, to look backwards at that problem. I don't know what the results of their analyses are. I haven't focused on that.
Yeah, very good. I mean, that is a common problem with a lot of the things, as you said, in the area, in the pre-satellite era. we just missed an awful lot of stuff. So it's very hard to know what the truth was. If you don't know what the truth was for rare events, it's very hard to figure out what the uncertainty around it is. But certainly there is a warming and a trend in the data that you presented. There's something about the storms that I was interested in, and again, Nicole put a kind of a related question in the chat. You said that the core pressure was decreasing, and there was quite a strong trend in the line you showed there. In my very basic understanding of winds, I would have expected maybe the wind speeds to be increasing if I saw a decreasing trend in core pressures. And just to give you two questions at the same time, Nicole's related question is, did you have a look at the size of storms, and maybe was this related to explaining the difference between a drop in core pressure without a corresponding rise in wind speeds?
Well, I looked at the data the same way. I looked at that core pressure drop and said, why is the wind speeds not increasing? And the only thing I could think of is that the circulation was actually enlarging, so that while the core pressure was dropping, the measurements we're actually getting were from a larger diameter synoptic scale feature.
Yeah, so the pressure gradient force would be constant. So that would actually link Nicole's comment to your answer, where the core pressure goes down, but because it's a larger storm, your pressure gradient doesn't change, and therefore your wind speed will be constant. That's a really interesting one. I think that's a good one, for anybody who's thinking of dabbling into this a bit more. That'd be a really interesting one to try and answer in maybe some of these higher resolution analysis things, and with some of the more recent storm tracking codes that take sizes into account. The last question from me then is kind of an offhand comment you gave at the very end, where you talked about tropical cyclones turning into extratropical cyclones. Okay, I understand that concept, but you mentioned this term entrenched tropical storm. What is an entrenched tropical storm?
I think I was probably referring to a trans-tropical storm.
And so what do you mean by that? Is that something that retains the characteristics of a hurricane beyond a certain latitude, or?
It's actually when the tropical storms undergo the transition. It's not a snap transition, it takes a period of time. And when they exited our study box, they may not have been completely a cold core system. They may still have some characteristics of the warm core. And so we call them trans-tropical storms. They're undergoing it, but they haven't made that full flip to a mid-latitude cyclone.
Brilliant, very good, very interesting. Okay, great, thanks, Gerry. If anybody else has any questions for Gerry, feel free to speak up. There's one in here from Paul Moore. Did you superimpose the ENSO state on the results? So taking into account the La Nina on the Atlantic. I was wondering that myself, does La Nina, El Nino, La Nina, does that have an effect on North Atlantic storms?
Yes, I would say that. I did not specifically look at that. We were trying to just focus on whether or not there was an increase in storms related to the sea surface temperature. The issue of going further as to just say, well, why is this happening? That's what I was hoping I would lead you all to kind of think about, because as you move the Gulf Stream further north, the baroclinic zone at that northern edge becomes much more defined and much sharper, and therefore much more likely to have some severe storm development. You also have a shift in the jet stream. The jet stream is being pushed farther north. So you have jet stream, the baroclinic zone, you have the sea surface temperatures and all the complications of that, as well as currents. And there are other things which may have very small effects, but curiosities, and this is a curiosity I put forward with not any or much justification behind it. Shipping routes between the US or North America and Europe follow that north branch. They follow the Gulf Stream. And we all know that the shipping lines burn a diesel fuel, and that diesel fuel, when it is emitted and it's burnt, the byproducts are cloud condensation nuclei and ice nuclei. So with large numbers of ships transiting that route, is that having any secondary effect, along with these other things we've talked about, on the generation and the intensity of these storms? It is a very complicated problem, and that's why I didn't jump in and say, you know, this is all due to something or other. This is just kind of a start at the what is actually going on up there. An interesting study would be to look at radiosonde soundings from Iceland over a period of time and look at the change in baryclonicity as a function of these two large blocks. That's another thing which I would think could easily be done.
Yeah, very, very good, very interesting, and yeah, good point. I mean, these things are a lot more complicated than they look when they're fully formed, and their genesis and their destruction involves potentially many variables, and it may be overly simplistic to try and correlate with one when there could be multiple things going on. That's interesting. I wouldn't have thought of the shipping tracks at all. I've seen some other research papers talk about the influence of shipping tracks on local weather, but not one looking at the North Atlantic region. So that's an interesting one. And the shift in the jet stream, as a few papers have been looking at that as well. And that's an interesting one because it could go either way, right? I mean, a shift the jet stream could actually cause the destruction of the core of a hurricane at a certain stage, whereas if it weakens and moves in another direction, it could cause the hurricane core to stay intact for longer and shift the tracks. So it's complicated and involves many variables, as you say, lots of future research to be done here, but a great starting point. And thanks very much, Gerry, for your very informative talk that you gave to us this evening. You've presented really interesting results and also left really good questions for us to think about in the future. So once more, could we show our thanks to Gerry for a very interesting talk and really good question and answer. Thank you, Gerry.